The 7 costly and complex challenges of big data analytics. Hi, my name is Thomas Hazel, and I'm the founder and CTO here at Chaos Search. At Chaos Search, we transform customers' cloud object storage, like Amazon S3, into a massively scalable database, going after use cases such as observability, security, and application insights. Today, I'll be talking about the second of the 7 challenges of big data analytics. This episode will cover data preparation, the building, scaling, and their maintenance. We will outline what they are and why they're important. But the focus will be on the problem one encounters at scale. You should see these episodes as a series where each leads into the next. Think of them as a journey, a data journey, where we'll examine everything from the actual sources generating the data to the extraction of value from them. So let's get started. What is data preparation? A pure definition, data preparation is the act of manipulating or pre-processing raw data which may come from disparate sources into a form that can readily and accurately be analyzed for business purposes. Preparation is typically the first step in data analytic projects and can include many discrete tasks such as data ingestion, transformation, fusion, cleaning, and finally, augmentation to ultimately be sent to the next phase of a data pipeline, such as a database. Such data preparation supports several purposes along the data journey. Each potential task manipulating the data is to get it into a normalized schema to be consumed in a consistent manner. And depending on source data, more manipulating is needed than, let's say, others. For example, operational data for log analytic use cases typically do not need fusion, cleaning, or augmentation. However, it more often than not requires data transformation to be normalizing it into a consistent schema. Today, sources will utilize data protocols like JSON to describe events, which can be quite complex in their nature. Another example is in business intelligence use cases, where data certainly is transformed, but also manipulated by fusing data with other sources, such as fact tables, or clean the data due to different formats, such as phone numbers or street addresses. As one can see, this aspect of data journey can get complicated and messy, often described as the toil of data analytics. Data preparation, even at small scale, can be responsible for 60 to 70% of overall work associated with running an analytic project. As a result, a profession has arisen calling data engineering to directly focus on building, scaling, and maintaining preparation in a data pipeline. And here's the dilemma. It does take time that businesses don't have when trying to derive value from data. Along with DevOps and SREs, data engineers spend weeks setting up data pipelines and their corresponding preparation logic. And once complete, any change to the data schema can send ripple effects throughout the data pipeline, all the way to the database where the DBAs are now getting involved. And when data begins to significantly grow, the time, cost, and complexity of data preparation is just multiplied that much more. You can imagine the stories any company might have trying to maintain this hairball of complexity. I've heard stories that just a database schema change alone might take up to 6 months to be approved. As a result, there are numerous products that have been built to support such problems. Some of the same names we mentioned in our previous episode, challenges of data pipelines. There have even been new architectural philosophies employed, such as data lakes, where data is sent directly from the source to the data lake destination without change and stored in its raw state in services like cloud object storage. This removes the need to perform schema on write preparation, but does now require schema on read post-analysis and code execution. This technique became popular with solutions that were based on Apache Hadoop, Yet this really did not solve the problem, but deferred it. The preparation was still required, just delayed. And in some respects, it became more complicated and costly. It's like procrastinating to do a homework assignment until the day before you have to get it done. Not a good idea. During this time, new types of databases became popular that were geared towards less structured data sources. However, these types of databases were traditionally used in very specific use cases and were not seen as general purpose. In other words, very niche. And when it comes down to scale, these new databases or data lake solutions require an army of DevOps and SREs to deploy and maintain. Now, there has been a movement to rethink lake architectures. For instance, leveraging the simple in, where data is streamed in its raw format, cataloged within the lake, and when the data is needed, such as a data warehouse, a pipeline is dynamically created to move this data where preparation is not removed, just deferred. This really does not address the problem, since it really only works well for replaying data, and any real-time requirements are not supported. But it does allow for dealing with the pipeline when you decide you need it. For instance, in use cases like security data lakes, where you need to go back weeks, maybe months to analyze a problem. Not ideal, but an answer to the data retention requirements, even though it might take days to replay. So are data preparation issues, particularly at scale, something we can't solve? Well, here at Chaos Search, we didn't think so. The problem with data preparation is the toil. And this toil has a direct relationship to the technology and architecture used to store and ultimately analyze the data. We know that sending data in its raw form is simple, fast, and cost-effective, particularly when leveraging cloud object storage. The issue is taking this raw data and manipulating it for analytical consumption. What is needed is a solution that supports schema-on-read ingestion simplicity with schema-on-write database performance, where the schema-on-read toil was simple, automated, instant, and of course fast. And this is what we did here at Chaos Search. We created a technology and architecture that gets the best of both worlds. Use your favorite pull solution, such as Fivetran or Matillion, and stream it to your data lake, such as Amazon S3. Also take your favorite agent, such as Logstash or FluentD, and stream it to your data lake as well. From there, we automatically categorize and fully index the data in near real time, but does so in a format that allows for high performance preparation post-ingestion. We call this concept the Chaos Refinery, where the user can instantaneously publish views to the data where the manipulation is dynamically executed when a text search via Elastic API or relational SQL via the Persto API is queried. And when the data is big, I mean really big, where ingestion is terabytes per day and up, and petabyte scale is the norm with trillions of events being generated, it's a game changer. One can start to see a theme when it comes to resolving the challenges of big data analytics. The idea of leveraging cloud object storage as a destination is key to scaling IT infrastructure. And depending on how far you take object storage, the more benefits you will see. In the case of Chaos Search, we went all in to a point that there is no other persistence layer within our solution. The difference is that we moved away from these classic technologies like inverted indices such as Lucene or columnar indices such as Parquet. Both are fine technologies in a vacuum, but when it comes to messy schema or dynamic change or reading and writing to and from cloud object storage, they are truly not a good fit. Now, if you're interested in learning more about the Chaos Index technology, as well as the Chaos Refinery, please go to our website, chaossearch.io. But until then, please join me on our next episode. There will be a lot more discussions between databases, lakes, and warehouses, and their corresponding techniques and architectures. See you next time.